Hello, everyone, and welcome to Digital Twin Digital Thread for Operations webinar. My name is Juliana, and I work in marketing here at MicroCAD. And today's presenter is Phil Marshall, one of our applications engineer. By the end of the webinar, you will know the benefits and the work that has to be done in order to implement digital strategy, a digital twin digital thread strategy. And that's definitely worth 30 minutes of your time. Throughout the webinar, you can ask a question at any given point on the left-hand corner. You can ask Phil to revisit a step or ask any questions, as this is your time and we want you to make the most of it. And in the upper left-hand corners, you will find links to our social media, YouTube channel, and MicroCAD website. So yeah, make sure to check our YouTube channel. We post all of our webinars there at the end, so you can share with colleagues or watch it on your own time. And without further ado, we'll pass it on to Phil.
Good afternoon. Thank you very much. Let me share my screen. So you see digital twins and digital threads, which is what we're talking about today. So what we're talking about in digital twins and digital threads is the concept of working the operations side of your facility. And we know that managing a large facility is really tough. You're expected to meet regulatory requirements, plan renovations, manage all facility projects, and respond to emergencies. The digital twin, digital thread concept offers some real opportunities for making your life easier, because it puts all the information in a single place, guaranteed to be current and accessible by all people from anywhere on any device. And it provides standardized processes for working with that data, so any changes to the physical building is reflected in the digital model. It provides operational information, including safety, regulatory, and environmental data, all geolocated within the model. And it gives you a simulation of the automated processes that you've built into the smart building, like manufacturing lines and processes, HVAC, lighting, and security, so that if a change is considered, the manufacturing engineer can test that change in the digital twin without affecting production. But this isn't only for owners. Architectural practices and general contractors will also benefit by implementing a digital twin. This webinar details the benefits and the work that has to be done to implement a digital twin, digital thread strategy. First of all, let's define what we're talking about today. A digital twin is simply a computer model of a facility. It differs from a BIM model because a digital twin includes much more information for the operation and maintenance of the facility, whereas a BIM model is focused on the initial design and construction phases. However, a BIM model is a good place to start for a digital twin. And the first digital twins weren't in the AEC industry, they were in aerospace. That industry has used simplistic computer models for stress analysis, structural frames, and aerodynamics since the 1960s, but it wasn't until the 70s and 80s that they began to model the complete weapon system and use that model for applications like reliability, failure analysis, and maintenance. The digital twin, although it wasn't called a digital twin at that time, allowed them to think of the entire system as one object. Without DoD funding, however, the AEC industry moved a bit slower, but ArchiCAD in the 1980s allowed a designer to model a simple building. With similar functionality, early Revit followed and was acquired by Autodesk in 2002. But widespread use of these tools were limited by the performance of the then current PCs. Along came the perfect storm of PCs doubling in speed with each generation, also known as Moore's Law, dropping prices of RAM chips, software improvements, including incorporating time into the model, like Navisworks does, allowing for construction sequencing, and BIM, especially BIM. This is where architects, designers, and construction professionals could actually make some money with models. Now we can use BIM models for entire campuses or complex buildings and include the information that is valuable to everyone, designer, builder, and owner. The time is now right for digital twins. But the way most people think of these complex computer models is as a snapshot of the real facility. That concept doesn't allow for some of the biggest benefits of a digital twin. As well as representing the physical of the structure of the facility, a true digital twin includes digital threads or process information that tells how the structure operates. This would allow the digital twin to simulate the control systems incorporated in the building, and these are getting more complex as buildings are getting smarter. This would include manufacturing processes, seeing products move on the factory floor. Simulation of material handling and work processing is part of the digital twin, and operational systems like elevators and heating cooling systems that work off of sensors. Indeed, the Internet of Things means that smart buildings will become smarter. A good digital twin will include the logic and work like the functions do in the real building that these IoT sensors control. And no building remains static. A digital twin model would enable owners, architects, and builders to plan, visualize, and optimize building renovation projects and help to execute the change from pre-con through construction and commissioning. The implementation of a digital twin leads benefits not just for the owner, but also the architectural team and the builder. These are typical benefits from a digital twin project, but they're not necessarily exhaustive. We see that specific users may find additional benefits. Single source of current truth from anywhere. This first benefit is one of the biggest, a single place to get reliably current information. No more searching through CAD files or pulling out drawing sets or worrying if the as-builts are truly as-built. Everyone knows where the most recent data is. Importantly, users can access the data for using any device, laptop, workstation, tablet, phone, and from anywhere that there's an internet connection. The office, the factory floor, the construction trailer, all of this makes the data available and reliable. Visualization. Since we have geometric modeling of the facility, we can use it for visualizations, whether as marketing material or checking clearances around machines or verifying the exit path in the building. We can see the 3D structure around us, and we can animate that motion for familiarization and training of new hires. So by using these visualization tools, we can make the real building be replicated in a digital model and use it for letting people see what it looks like, planning changes, and helping train operators and users within the building. Complete services to client. For the architect, it's important to build relationships with their clients and provide as many services as they can. For the owner, it's important to build a relationship with an architect so that they know the buildings and can work with them and plan their changes in the future with a level of trust. The digital twin ensures that the partnership continues after initial construction as the client maintains the digital twin and considers future renovations, and the architect is involved in also maintaining the digital twin. Easier commissioning and handover. The process of completing a construction project, whether it's in the initial build or a renovation, requires the owner and the builder to confirm the structure meets the contractual specifications. With a digital twin, the process is well defined and all the documentation is easily available, making the commissioning process smooth and easy. Operational safety. Operating the facility in a safe manner is paramount to the owner. With the digital twin, safety risks can be identified and mitigated, with the risks of and actions documented in the model for all to see. Before a maintenance project is begun, the project manager can identify all of the risks from the model and plan accordingly. Any lockouts can be identified and planned for. Lifts can be planned ahead because the digital twin has the equipment weights and center of gravity. Asset management. In the digital twin, each asset object can be identified and metadata about that asset, acquisition date, maintenance schedule, spare parts locations, etc., can be easily extracted. Metadata about that object can be queried and shared with other corporate applications. Simulation of processes. The digital threads within the digital twin emulate control systems in the real facility. As such, they represent manufacturing processes, a product flow on the factory floor, whether they're controlling access, use security keys, or HVAC control for temperature controls. When the manufacturing engineer wants to try different logic for the manufacturing process, for example, they can simulate it in the digital twin and test those changes without affecting production. Energy optimization. More and more owners are concerned about energy use, both because of the cost and social awareness. Green buildings can be built, but they have to be operated in a way to maintain that greenness. Automated HVAC systems, moving shades, air control systems, all are ways of operating the building at maximum efficiency. The digital twin could be used to analyze energy use and model the control systems. It can then be used as a basis for the testing of alternatives. Facility management. The tasks of facility management, space allocation, maintenance, regulatory compliance, environmental measurements, all can be made easier with a digital twin to manage the vast amount of data and have all of that data tied to a location in the facility. Reports that are required can be generated from that information and sent to the appropriate agency. Planning platform for alterations. No building stays unchanged over its lifetime. Planning for renovations or remodeling is more reliable using the digital twin as the current state and testing different alternatives. The digital twin represents the as-built as it is right now, a trustworthy set of information. Mechanical systems like power and air can be adjusted for the new changes to see the impact on utilities. And a standardized change process. Having a digital twin as a starting point for all changes means that the as-built can really be trusted. The consultants and contractors making the change will provide updates to the model per the BIM execution plan for that particular change. And that way, the digital twin retains its currency over the course of the years as you have more and more change projects. So we see the digital twin provides benefits for the owner, the architect, and the builder. Many of these benefits are similar to what we know are reasons to use BIM for new construction, but the digital twin has many more operating information than the traditional BIM model, and it retains its value and the benefits throughout the entire lifespan of the facility. So how do we build a digital twin? There are technology tools that enable the creation and maintenance of a complex digital twin. These are tools that are available and in use now. In most cases, the digital twin will be built on a BIM foundation. BIM has become a required part of construction projects. For new construction, the BIM process results in a data-rich model of buildings and utilities in an as-built state, perfect for inclusion in the digital twin. And geolocation can be used to position BIM models of different buildings on a campus. For existing buildings and structures, LiDAR scanning, either from the ground or from a drone, gives you a dense point cloud suitable for use in the digital twin. From the point cloud, we can model faces and objects and turn that point cloud into for example, a Revit model that we could use in the digital twin. The image at the lower left on this particular slide is the result of a LiDAR scan of an area, and you can see the quality of the modeling that came. The red brick building in the center is a Revit model that was put down on top of the cloud model, but the other buildings are directly from the LiDAR scan. The automation in the smart building can control doors, elevators, HVAC, and other devices. This control logic can be added to the digital twin as necessary to simulate that behavior. All right, so after talking about this digital twin, if you want to investigate it further, that's great. The best first step is to consider where there are opportunities for change within your current workflow. These would be applications with large payback and little upfront costs. Think through the benefits we mentioned already and see which ones stand out for you. Once you have some concrete ideas about applications, consider how the digital twin strategy fits into your company's basic mission and operations. Senior management support is necessary because the digital twin will become a cornerstone of your company's facility strategy. Then you can quantify benefits and costs for the identified applications and calculate an ROI. Digital twin projects are always implemented in small steps. Take a single building, scan the exterior, scan the interior, add mechanical, and then go on to the next building. So it might take a while to fully implement the twin for your entire campus, but you can start to get the paybacks from the buildings that are modeled as part of the implementation. For all of this, you'll need a trusted partner who can help you define and implement your digital twin. MicroCAD can provide that expertise. When you are ready to begin your digital twin journey, reach out to us. Before we catch up on the questions, let me mention that MicroCAD presents a series of webinars aimed at helping you be more effective. Take this opportunity to tell us what topics you would be most interested in by entering them into the chat box. We really want to address your questions, address your needs. Okay, now on to the questions.
Thank you, Phil, for that wonderful presentation. And as he mentioned, you can ask a question on the left-hand corner. I already see some questions coming in, and the first one is, what kind of accuracy can you get with a scan point cloud?
That was accuracy?
Yes.
Oh, okay. Yeah, sure. That really depends on the particular devices that you're using and what the intent is and how you're using it. Each of the devices that we use mostly Leica scanners on the LiDAR side, and though they have a specific resolution that is the best they can do, the way we use it results in the accuracy we get for a particular model. For example, on a very large building, I think this was about a 400 by 250 foot building, we ran the drone at a fairly high altitude to do a quick scan, and that came back with an accuracy we calculated of being within 3 inches of reality. If we wanted to reduce that accuracy and get it really sharper, then we could have taken more passes at a lower altitude and then improved the model. But for the purposes that we were looking at, 3 inches was great. When you go interior, then it's usually the number of setups that determine your accuracy. Again, the resolution is device dependent, but the accuracy depends on the way you use it. And if you have more setups so that you have more points in your cloud, then you can increase their accuracy. We were doing accuracy in that particular project, interior accuracy of around an inch, but with more setups, you could get down to probably half an inch. So you can get some highly accurate models this way. I'll point out that in both of those cases, they had some AutoCAD, what they called as-builts, and the mistakes and the errors in the as-builts were just much more than any accuracy issues you'd have from the scanning. So the scanning paid for itself in clarifying errors on the paper as-builts.
Thank you. Another one says, these models must be huge. Can they really be responsive on the cloud? What about data cost?
Yeah, these are huge models. You go to a point cloud and you got gigabytes of data. To address your question, however, remember that when you're on the cloud, in the Autodesk world, they have a virtually unlimited amount of processing power. So to process those models, they can line up multiple servers, set up multiple threads, and rerun them on multiple servers so that the processing time isn't as slow as you might think. It actually comes by quite quickly. Going in the cloud from a point cloud to a model, a usable model might be 20, 30 minutes. If you did it on your own computer, it might be overnight. But by going and using the cloud, then there's some value there. What we've seen most of the limit tends to be on the end user device. So if you're using a tablet without a lot of memory, then you might see some drop off of the resolution on your tablet. So there are some minimum hardware requirements that we have recommended for people who are using devices in the field. As far as the cost goes at this point, and as far as we know in the future, Autodesk does not charge for storage. So we can put those gigabytes of data up on the cloud, and there's no charge for that. So you don't have to worry about the costs on the cloud.
Got it. Thank you. And the last question I see is, what software are you using for this?
Yeah, the answer is that an every project ends up being a mix of software. In just about all of these applications, the authoring tool is Revit. Revit is the BIM tool that Autodesk has, and it has become the default standard for BIM modeling. Some organizations use secondary authoring tools, things like AutoCAD or SolidWorks or Inventor. And if those are used for modeling, then we just add those as authoring tools. And those models then get added to the digital twin. So we might have a mix of authored tools to make that digital twin. This part of the digital twin might come from a SolidWorks model of a boiler. This part of the digital twin might be a conveyor system modeled in Inventor, and the building might be modeled in Revit. That's fine, because in the digital twin, we don't care about keeping it all the same. We just want to make sure that we have the geometry and we have the locations. As far as the access to the digital twin, we're hosting it on Autodesk's Forge data platform. And from that Forge data platform, we're using a lot of the Autodesk Construction Cloud services. So we use the doc services to give us document management, the build service to do some of the interactions for the field, and a couple of the other services depending on the specific things that the customer needs. And for a lot of our customers, we found that there's some additional tools, either non-Autodesk tools, that we need to use to give them particular capabilities. So the end result is customized for each particular customer, but the heart of it is on the Forge platform using Autodesk Construction Cloud.
Thank you, Phil. You can move to the next slide. So I think that was it for today. If you want to learn these topics in detail, you can always take a custom training with Phil or someone else on our team. We also offer group classes online. So be sure to be checking the MicroCAD website for future webinars. And there you have our contact information for you to contact us in case you have any doubts or have any requests. We'll be happy to answer that. And that concluded our webinar today. Thank you everyone for attending, and thank you, Phil, for that wonderful presentation.
Thank you.
Thank you.